Welcome, everybody, to our webinar today, discovering and discussing the differences between three lightweight Kubernetes distributions, k0s, k3s, and MicroK8s, or MicroKubernetes. So we're really going to be looking at how to choose lightweight distro, and welcome all to our session for today. Now, my name is Kevin. I am a Senior Solutions Architect at Mirantis, and I will be your host and your presenter for today. My background is mainly in everything DevOps delivery and deployment processes. So I work with a number of customers for the last decade or so, just working on their solutions to the infrastructure and deployment challenges, and working on customer workshops or webinars like these ones. And and then folks that I've worked with are mainly kind of in the actually varies a little bit, both in the financial industry to retail to healthcare, so a little bit of everything. So in today's webinar, I want to cover a few things. First of all, the differences between the various lightweight Kubernetes distros and plain vanilla Kubernetes. Why do we need it in the first place? We want to do a comparison between the three different lightweight Kubernetes distributions, k0s, k3s, and MicroKubernetes. Now, I know, of course, there are others out there. These are the ones that we're kind of hear a little bit more of. So this way, that's why we're using these to start off with. Looking at then, after we look at the comparisons and capabilities, when would you want to use one versus the other? What are some decision criterias that could help you in your decision-making process? And kind of a deeper dive into k0s as well. So to start off with, vanilla Kubernetes, or out-of-the-box CNCF Kubernetes, we know it is powerful. A lot of us are getting into it, and a lot of people are already on it. Deploying them into their production environments, it scales really well. It's very robust. It gives a whole range of capabilities and supports a whole range of workloads. Very good. But at the same time, all that power, of course, comes with um, a more significant resource requirement, right? It becomes more resource intensive. So, that is good when you have a massive data center or when you're perhaps on the cloud and you're able to scale infinitely. But when you're looking at situations such as using Kubernetes for personal development or a localized development, let's say, for example, or if you look at deploying Kubernetes on kind of further out edge, near edge, or towards the edge scenarios, you may not have the luxury of having an entire server farm where you're at. Right? I've spoken to customers, some of them have one or two consumer grade level machines, perhaps. Some perhaps have a rack in the back of the store. Some just has one computer sitting there. So that limitation really presents some challenges when you want to implement a full-fledged Kubernetes at that environment, right? Because you have the resource constraints for one um, at the edge sites at your and let's say retail site or at a branch or so on. So there's a resource constraint. Secondly, when you're looking at development environments, to spin up an entire Kubernetes cluster is again, it's pretty process intensive. There's a number of things you need to go through, right? So there's a problem of then, okay, I need to quickly get an environment where I could test in, or I need to do some unit testing and development in. Just waiting for that environment to come up is taking time away from development time, right? And when you start putting that into your CI/CD process, your continuous, the word continuous then no longer works because it's not continuous. You're waiting and waiting and waiting until something comes up, right? So setting everything up. So that's where the lightweight Kubernetes comes into play. It was kind of built um, for some of those reasons as well. And when we think about lightweight Kubernetes, it's really a stripped down version of Kubernetes. They have the core functionalities of Kubernetes, but it reduces the resource consumption, making them really ideal for your personal devices, your development laptops, or on the edge locations in your retail, the servers or the machines that will live on the edge sites. And also, it'd be much more powerful when you include them into your CI/CD processes because you could essentially, if you need to spin up and tear down environments really quickly, it takes minutes to perhaps hours as opposed to an entire day to get everything set up. So, main advantages we talked about ease of setup, we talked about low resource usage. And then the third thing is the versatility as well, right? These lightweight Kubernetes distributions are suitable for majority of environments from anywhere from your local deployment even to your hobby deployment on, let's say, Raspberry machines, all the way to your edge locations where you can have a consumer grade or even a single server rack there. So the three that we'll be talking about, like I said, is going to be k0s, which is our Mirantis zero friction Kubernetes distribution, really focusing on simplicity and ease of use with a straightforward setup and a small footprint. K3s, which is Rancher's lightweight Kubernetes distribution, taking Kubernetes to, I believe um, the message was to IoT, low resource environments. It's also got a pretty straightforward setup process. We'll talk about that in a second as well. And a more simplified operation, stripped down version of Kubernetes. And MicroKubernetes, which is essentially integrated with the Ubuntu system. If you've done a manual Ubuntu installation, you'll probably see, one of the screens, you have all the different components that you can pick, and then MicroKubernetes will be right up top. You can pick those, right? And it, again, has a relatively simpler installation process. It's a bit more, um, uh, I wouldn't say less stripped down, but the way that it works is slightly different. So we'll talk about that in a second as well. Okay. So the first thing to do, let's do a side-by-side comparison of these three um, Kubernetes environments. So as you can see over here, let me get my laser pointer up. Notice that the on the background is relatively similar, right? Developer k0s is ours at Mirantis, k3s is by Rancher SUSE, and MicroKubernetes is by Canonical, the Ubuntu creators. The interesting thing to look at is the programming language of the three. I mean, you've got k0s and k3s built on Go. It's a typed, static type language, and it's compiled, giving a slight performance advantage over MicroKubernetes, which is built on Python and Shell, which, of course, Python has that bytecode compilation, but it still has to go through that extra layers. So giving a slight a performance disadvantage that we'll see in a bit as well. But you see it's actually relatively slight. It's really good though if you need to make any changes to it because the language, of course, is a bit more well known. So if you're doing some open source tweaking, it does give you that advantage over there. Now, the operating system front, k0s runs on both Linux and on Windows Server on an experimental mode. So we want to make that disclaimer over there. So if you do run this on Windows Server, consider it experimental at this point. There's active development. We want to make sure that if you are doing that, please do let us know, and we can work with you on making it much more hardened. K3s, primarily on Linux, and MicroKubernetes has a pretty comprehensive coverage because it does run on the Linux VM in the background, right? So it does have Ubuntu and Linux, and it comes out of the box in Ubuntu. And when you look at Windows and Mac OS, it runs Windows. I believe it runs on Hyper-V or VirtualBox, depending on how your virtualization is. And on Mac OS, it uses multipath, so it essentially runs an Ubuntu VM in the background, and then MicroK8s on top of that. And the deployment method is pretty similar of the three as well. It's a 1 to 2 command deployment. Difference again being k0s and k3s is presented as a single binary that you download, or you can just run the shell script to deploy it onto your machines. Whereas MicroK8s uses snap package, so you do need the snap installer, do a snap install of the MicroKubernetes, and it goes through and installs all the different commands there. Now, in terms of security, as far as my research goes, and if any folks out there sees otherwise, please do let me know. k0s is currently the only one that I know of that has FIPS 140-2 accreditation, allowing you to have the federal level uh, security and encryption. And again, I think there are ways to make K3s and MicroKubernetes FIPS compliant as well. But of course, when you think about FIPS compliance, that you have to do the whole lot anyway, right? You have to make sure your operating system is FIPS compliant. You have to make sure that also um, your workload is also FIPS compliant. But the thing to note over here is that k0s will not get in your way. Um, and we actually could allow you to have this built using FIPS 142 certified components, right? So with that build, you could then put it into your environment and then worry about making sure your operating system is FIPS validated and or compliant, and also your applications. So we're not getting in the way of your security there. So let's do a deeper breakdown into the three different uh, distributions. And we'll look at it in a couple different areas. The first thing I'll do is break it down in terms of the installation and the architecture. And then we'll look at a side-by-side comparison of a few metrics of the three different distributions. So let's start with k0s. The k0s installation comes as a single binary. You go through and it's essentially an install script that goes through. And the binary includes essentially everything you need for it to be up and running. So you have your k0s, the images, you're doing air gap as well. It's all included in the binary, and then the components that are required. We could also do fleet management via Cosmotron and Cluster API, which I'll go through in a little bit more detail later in the presentation as well, on how that could help you with deploying multiple clusters in multiple environments. And in this way, your operating system and your upgrade can be essentially independent from each other, right? You get a k0s binary. If there's any security updates, you can just install the k0s binary, and then everything is updated independently. And then when you have a multi-node cluster management, we do have an out-of-the-box tool called k0s control or k0s cuddle, depending on how folks like to um, say the CTL side of things. That helps with the install, upgrade, backup, restore, and reset everything of a k0s cluster. So with k0s cuddle, you have the nodes ready, and then we could set it up using k0s cuddle. And later on with Cosmotron and Cluster API, I'll give you a very high level view on how you can actually deploy individual machines as well, without having to set nodes individually for that environment to have k0s installed into. Okay. Now, when you look at the architecture of a k0s, it's slightly different to the others that you'll see, and I'll go through k3s and MicroKubernetes architecture as well. And you'll see that over here, we've got a true controller and worker separation within the k0s architecture. When you look at a traditional Kubernetes distribution, we do have our manager or control nodes. But at the same time, you're able to run workloads on your manager nodes. Right? You could actually cordon off to taints and tolerances to make sure it doesn't get used. But at the same time, you still have those additional components within your controller and manager nodes that actually allow workloads to be run, which of course, A, takes up resources, and B, if not configured correctly, you may have some massive workload running on your manager node, which is of course not a good thing to make sure that your cluster is running efficiently. So within k0s, we actually have only the management control plane components in the control, right? Nothing else. It's actually installed as a bare bones Linux process, so everything is pretty streamlined and runs natively. And connectivity between the controller and the worker is via connectivity agent. So at the same time, when you're connecting between your controllers and your workers, you only have to worry about one port in your firewall rules. So this way also increases the security, because as we know, the more ports you open up, the more, I guess, the larger your attack surface, right? Folks have more chances of coming in and look at your ways of getting into your system. So we reduce that by streamlining it down to just one port and having bare bones management only components within your controller. Now, when you're looking at K3s, and I apologize if anybody is from Rancher, I apologize for the diagram over here. I was trying to find a cool and uh, diagram for your installer. The best I could do is look at your page and perhaps look at some of the components. So if you do have something, let me know and send it over, and I'll make sure to use that in anything else that I do with K3s. Now, K3s installation, similar to k0s, also gives us a single binary installation, right? And once you have it installed, you can then add it to Rancher to perform cluster management after your installation. Now, again, as far as I know, I don't believe there's an installer for K3s. I know actually um, by Rancher, I should say, right? There are other open source installers out there that you could actually do some of those management activities with. I'm just not as familiar. So again, if you see any of those, if you do have any of those, I'd love to be educated on what some of those native installers are. In terms of K3s architecture, you see this is actually going to look a little bit more familiar if you're familiar with plain vanilla Kubernetes. Now, if you look at the server, so K3s, I believe, calls it a server and agent as opposed to how we normally call it as a controller and worker. But it roughly equates to the server is your controller manager, and then the agent is your workers, where you actually deploy workloads onto. And you'll see that you are able to deploy workloads onto your server if you like to, but again, it has all of the different um, components that are uh, common within all Kubernetes distributions. And I believe it also uses a tunnel proxy methodology of connecting over. So you see that differentiation there between k0s and k3s. Both have um, a secure, simplified server to or controller to worker connection. The difference really being the ability to run workloads or not, and the stripped down version of the manager nodes. Now, when we look at MicroKubernetes or MicroK8s, it's slightly different. It uses a snap installation, so you actually see the components that are being installed if you go to the GitHub repo on the package components. So you just run a snap command on your Ubuntu server, and it gets installed. Right, so it's not a single binary. You do have to do some scripting in this case. Cluster management, I believe you can actually achieve that by Juju. And Juju is more of I believe, a general purpose automation framework. So of course, there's more things that can be done. The flip side, I think it's not as tailored to MicroK8s distribution and deployment. So you do have to go through and find some of those automation steps in order to do your cluster management when you're doing MicroK8s. So when you look at the micro-Kubernetes architecture, now, for the longest time, micro-Kubernetes has been really for kind of single machine localized development. I know Canonical has pushed out a number of, excuse me, informational material that says you can do HA and multi-cluster. I haven't actually got too much information on the architecture, unfortunately, looking at the diagram. But you see, it's actually pretty similar. It's when you look at the some of the material that has been put out, it's actually much more similar to traditional Kubernetes in terms of the components that are included in there. So anybody from Canonical, if you have other architecture diagrams, I'd love to see them and be educated on that as well. Right? So, which then also means then, if you look at MicroK8s, the connection between the manager and the worker loads are going to be a bit more traditional. So you do have to have those multiple ports opened up, make sure they're hardened, and make sure that your environment is protected from the outer world as well. Right. So you do have to do a little bit more monitoring on that side. So that's kind of a breakdown between the installation process and the architecture of the three. But then you may be thinking, okay, great. We got some good academic background. How does that apply? So moving on, let's talk about some comparative analysis of the three different distributions in terms of some metrics that could be useful for your workloads. Okay, so when you look at the three, k0s, k3s, and micro-Kubernetes, you notice that because, at the end of the day, we are really stripped down and lighter versions of vanilla Kubernetes. You notice the components are going to be relatively similar. right? The default container runtime for all three of them are container D. Um, you also do have other um, options if you like to in terms of your container runtime as well, right? So for k0s and k3s, we all both have Docker as a as alternative runtime. Of course, Mirantis, we are also own the Docker runtime. It's called the Mirantis Container Runtime now. So we also have some of the native capabilities and support options when you're looking at the Docker runtime. And you could also use other container runtimes as well, both K0s and K3s. Now for MicroKubernetes, as far as the node, you've got an alternative of Kata in the underlying runtime. And that's as far as I see for now. Now, in terms of CNI, we do use different technologies. It really is also dependent on how perhaps your familiar level with the networking is. I know a number of folks have Calico Enterprise within their environment. So we do have the option of going to Calico for K0s, apart from KubeRouter if you like to, and of course also any custom CNIs. Similar to K3s, it defaults to Flannel and also has other custom CNIs if you need to. And then for MicroKubernetes, it has Calico by default and also Flannel. Now, the control plane data store is the interesting part where you see the differences between the three different distributions. Now, by default, K0s utilizes etcd just like vanilla Kubernetes. But of course, you can hook it up to any default, the other data store they like to, right, for more control and management in the backend as well. Now, K3s uses SQLite, and MicroKubernetes uses dqlite instead. So you actually see some of the data store and data plane performance differences later on when I go through some of the metrics. And then when you look at the minimum CPU, again, they're pretty stripped down. You notice that K0s and K3s is pretty similar because we are both tailored for edge and lightweight devices. So, you can run with as little as one CPU or vCPU, 1 gig of RAM, and about half a gig of memory consumption by default. Whereas if you look at MicroKubernetes, it does have a larger recommended minimum CPU and RAM at 2 cores and 4 gigs, but the memory consumption is relatively similar. We'll see some of those comparisons later on as well, right? So the numbers that you're going to see moving forward is actually coming from a research paper done. I've put the link at the bottom over here, and it's very comprehensive in comparing these lightweight Kubernetes distributions. So the first thing we're going to look at is, what is the idle resource usage of the three distributions? Now you'll see K0s would be in blue. I've tried to use the respective colors of the three distributions over here. So K0s will be in blue, K3s will be in the K3s yellow, and then MicroKubernetes will be in the Canonical Ubuntu orange over here. So when you look at these are all idle resource usages, both on the controller side and the worker side. And I've broken down by, well, actually, the research paper has broken it down. I've presented it over here by both CPU usage and memory usage. So as you can see, when idle, on the controller side, K0s uses a pretty minimal, well, they're all pretty minimal, but relatively speaking, the least amount of CPU while idle, whereas K3s uses slightly more CPU. Whereas when you look at the memory side, we're pretty comparable between K0s and K3s, with MicroKubernetes using a little bit more memory. So when you're doing your control plane deployments, you perhaps have to kind of think about the resource consumption on that side. Now, when you look at also things like um, your edge instances, where perhaps you'll have one machine or one server and you're deploying VMs on it, all these cuts into the same compute, right? There's no real compute separation if you're all on one machine. So you may have to take these two numbers and put them together and have a look at it, right? So when you look at the worker side of things, again, K0s uses kind of minimum CPU, whereas MicroKubernetes uses a maximum amount. And then you look at the memory, K0s does use slightly more memory at 4% more than K3s. So you look at your workloads, you want to think about, okay, is my workload going to be more CPU intensive, or is it going to be more RAM intensive? And then start thinking about what could be perhaps the more suitable option there, right? And then when you start looking at deploying pods, now there's two different numbers when we're looking at the performance over there when deployment. So one, we'll look at um, a relatively lighter deployment. We're looking at 24 pods, and you look at the pod creation throughput. You notice that at a 24 pod deployment, K3s does perform slightly better than K0s in terms of the pod creation. It creates 130.6 there and thereabouts pods per minute, whereas K3s we kind of lag behind a little bit at fewer pods per minute when you're going through the throughput. However, when you look at the latency, we do actually create the pods slightly faster than K3s, with MicroK8s kind of lagging a little bit behind on the two. Now, when you start deploying more workloads, on the other hand, so if you scale this up to 120 pods, the numbers change a little bit more, right? When you start having a larger number of pods, and this is perhaps attributed to the fact that the control plane in K0s has fewer components it has to worry about versus K3s and MicroKubernetes, we do have a slight advantage in throughput when you start going into more pods and in the creation. And the latency is and slightly less still to K3s with MicroKubernetes um, taking a little bit longer to make sure their pods are up, right? And again, I'll probably attribute this to the underlying technology, perhaps some of the connectivities, and perhaps the resource usage as well between the three different distributions. Now, the interesting thing on top of that then is this is now pod creation and idle resource usage. But now when you look at the data pane performance, so things like reading and writing of the data store and then perhaps data throughput within your workloads, you notice a stark difference between the three. So the throughput operations on the data plane, when you're looking at K0s, K3s, and MicroKubernetes on the left over here, you're actually able to process through more operations per second by quite a little bit more between K0s and K3s, with MicroKubernetes in the middle at 14,000 operations per second. And then when you look at the data latency as well, we're able to, at K0s, take only 11 milliseconds in order to process the data versus the slightly slower MicroKubernetes and K3s at 18.9. So I know there's about 7 millisecond difference between the front and the end, but when you're looking at things like your low latency and high frequency transactions, things like that, every little bit actually does help, right? So the throughput and average latency would you probably want to take that into consideration depending on your workload and depending on what your usage is. So when you put all that together, if we look at the metrics of idle resource usage, data throughput and latency, and then pod creation and throughput, and I've cheated a little bit. I've only put the 120 pod over here. So, to be fair, K3s did perform a little bit better on pod creation throughput when you're working with 24 pods. When you start looking at the higher workloads, then you see that over here, K0s would perform a little bit better in things where you need low latency and high throughput data. So things like 5G networking, perhaps telemedicine, imaging diagnostics, or smart grids, autonomous vehicles, or even things like industrial automation and control. Actually, this is where K0 started. I believe there's a customer that actually needed the industrial automation, and the need was to put it on V7 chips. I think it was very lacking in resources at the time. So K3s was created to kind of provide a stripped down version that was able to run on those type of environments. And then when you start looking at the smart shelves in retail as well, right? So looking at inventory management uh, and kind of looking for where things are, having this low latency and high throughput, I believe, would be beneficial for your workloads. If you look at K3s and MicroKubernetes, it does perform again relatively well as well. And when you're looking at smaller workloads, K3s does perform a bit better than K0s. So hopefully this will give you some idea of what would be beneficial for uh, your workloads. Again, of course, tooting our own horns a little bit, but this is not our research paper. It's actually an outsider research paper that's actually showing you some of those um, out of the metrics that we have over here in terms of resource usage, in terms of data processing, in terms of pod creation. We do actually win out a little bit where the RAM is slightly fewer. So look at Kubernetes, right? When if that actually does pique your interest, right? Having that performance benefits and the data throughput benefits. Um, Look at some of the background of k0s. K0s, like the other two distributions, is distributed as a single binary. So it's self-contained, which means any vulnerability or performance issues can be fixed directly within k0's Kubernetes. And we do also commit to if there's any CVEs found in Kubernetes and we have a fix, we do commit to having that put into the next version within 2 weeks, right? So you have your vulnerability patching as soon as possible once the solution has been found. And k0s it does have all the included host operating system dependencies and components. So we can actually have it compiled and packaged as 100% FIPS compliant distribution using the proper tool chain as comparison to the open source version. And because it's designed to be lightweight as a core, it comes with k0's cuddle to automate the cluster lifecycle management. And it works on any host operating system infrastructure and can be extended to use on any use cases with as edge, IoT, telco, and so on and so forth. And with true control plane isolation um, between the controllers and the workers, you have security in a couple different ways. One, there is no workloads being run on the control plane, which means there are no ways of connecting into the control plane connections, the components, apart from the connectivity agent port that's connecting the worker to the control plane, which means you don't have to configure different firewall rules. It's just a one. And then when you look at this in an edge and IoT deployment, you have, we see folks essentially have a regional site deploying the control planes. And then the edge sites only runs the workloads. This way you have 100%, well, close to 100% of all the available workloads for just your worker pods and your worker, your workloads, as opposed to having additional components on your edge sites taking up additional compute. Now, when you start looking at multi-cluster management, we actually have a new project out called Cosmotron. It's spelled k0s Matron, but we call it Cosmotron. And utilizing cluster API as well, you're actually able to simplify your cluster operations, and you can run this on any Kubernetes and reduce this cluster sprawl and control plane overhead. So essentially what happens is you install Cosmotron operator onto an existing Kubernetes cluster. So this is now Kubernetes on Kubernetes. And the Cosmotron operator will create and manage k0's control planes in that cluster. So use this natural pattern of working with custom resources to manage the life cycles of k0s. So it'll create things such as your pods, config maps, etc., to run and manage the control planes. So all that becomes your control plane components essentially becomes pods within your we call it the mothership cluster. And then from there, you could actually take that and connect it to any child cluster. And with the use the cluster API, you actually deploy child clusters onto any environment, be it public cloud, be it your virtual machines, and now also onto bare metal with k0's Cosmotron Anywhere that has just been recently released. So if you look at the differences between using Cosmotron and without using Cosmotron, traditionally, folks will run into the issue of cluster sprawl, where you have a management cluster where you have your controller nodes and you also have the worker nodes, which then connect to clusters, which also needs controller nodes within the cluster and the workers within the cluster. So you're adding additional overhead in your workloads, in your workers, and you have multiple controller plane components that you have to manage in all of your different clusters. But now with Cosmotron, we're able to deploy the controller components into, again, the mothership that can connect to multiple workload clusters with only the worker um, components in there. So this way you have a standardization of your control plane and also it reduces the footprint of your workloads. This is akin to how the public cloud essentially manages the Kubernetes as well, right? Where you have your EKS, AKS control plane on demand, and then you could then deploy workloads on top of that, however technology they're working with in the backend, right? So this way you then also bring your own workers from any infrastructure into your cluster control plane. Hopefully today's session has given you some workable information on the comparison between k0s, k3s, and MicroKubernetes in terms of their resource usage, in terms of pod creation throughput, in terms of the data plane throughput, and also perhaps some of the management and installation features of each of these lightweight Kubernetes distributions. Now, if what we covered today is of interest to you and you think you want to try out k0s, please do visit the two websites that you see on screen over here. The first one, k0s project, is the k0s distribution. So this is our lightweight Kubernetes. Go through all the installation steps are there. It's a single line install. It works on just about anything. I've got about 3 of them running on my machine right now on VMs, one on a Raspberry Pi. So it's really lightweight and simple to spin up and tear down if you'd like to just test it out. And I would certainly urge you to visit cosmotron.io. That's k0s motron.io to look at the multi-cluster management solution, Cosmotron, and see how that could perhaps help with you reducing your cluster sprawl and deploying your Kubernetes clusters on your edge environments. So with that, I think we'll end the webinar. I hope you all have the great rest of your day and the week, and look forward to seeing you in a future webinar.